Welcome into this week's Degrees of Science. Now, there's been a lot of push for alternative sources of energy production. We talk a lot about wind and solar, but today we're going to talk about nuclear power. And today we're talking with Dr. Matthew Memmott. He's a professor of chemical engineering at Brigham Young University. So, Dr. Memmott, I guess the first question when we start talking about impacts of nuclear energy, but how exactly is power produced?
Yeah, great question. So it turns out that when you have a very heavy element with a lot of neutrons and protons in the nucleus, like uranium, when you hit it with a neutron, it becomes unstable and actually splits into two new elements. And it also creates several new neutrons that can then go on and repeat that process. And so when you're making power using nuclear energy, what you're literally doing is taking this uranium and hitting it with neutrons and creating this chain reaction where you continually split new uranium atoms. And then that heat that's generated, which a lot of heat is made when you split a nucleus. That heat then heats up the water, which then turns it into steam, which then turns a turbine, which generates electricity. So it's just like using heat from a coal plant or a natural gas plant, except that it comes from splitting atoms instead of from burning things.
So, we've done coal power and a lot of different stuff. How safe is nuclear power production?
So a lot of people wondered that same thing. And a few years back in the early 2000s, a couple of scientists actually endeavored to look at that question analytically. And they went through and gathered data and assessed different circumstances in commercial power production and came up with a chart that shows the number of deaths per terawatt hour per year of all the different types of electricity production, as well as the fraction of the US electricity market that they supply. And at that time, the very lowest deaths per terawatt hour per year at about 0.03 was nuclear, closely followed by solar, which was slightly higher than that. Really, the answer to that question is even though nuclear produces about 20% of our overall electricity in this country, it is the safest power production method that we know.
So we were talking, green energy, whether solar and wind and nuclear. How does greenhouse gas production, how does that compare with wind and solar when we talk about nuclear?
We rate the greenness of these things with respect to global warming by how much CO2 is emitted. But when it comes to the actual production of electricity, wind and solar don't make any. And nuclear is right there with wind and solar in that no emissions are created during the operation of a nuclear power plant. And so it is, as far as green is concerned, one of the best green energy sources we have. In fact, 50% of the carbon-free energy in the US is from nuclear.
So one thing that people have worry with is what happens with the nuclear material after it's spent in the production. How is that disposed of, and is there any worries people should have about that?
Yeah, great question. It turns out that the leftover waste from a nuclear power plant is really three different things. One, it's the leftover fuel that didn't get used, and that's about 95% of nuclear waste, actually. The second thing that it is the leftover pieces that uranium atom splits into as it's making the energy. And the third thing is some of the uranium doesn't actually split. Instead, it absorbs the neutron and becomes plutonium and americium and curium. And that's really the three things that are in nuclear waste. And what happens is when that nuclear waste is done, when we can't make any more power out of it, we take that waste out, we stick it in a pool of water for between 2 and 10 years, depending on the reactor and the fuel type. And that's to shield people from the radiation, and it's also to keep the heat from building up, and the water cools it off. Once that's done, we really have a couple of different options. One option that we intended to follow through but have not yet is to stick that in a specialized container that can be shipped across the country, send it out to an underground repository somewhere, and then keep that fuel for a while till we know what to do with it. The second option, which has ended up being what we do, is we take that fuel and we stick it in a concrete metal-lined cask that is just as robust as you could imagine. It could withstand falls off of buildings and train wrecks and airplane crashes, really solid. And then we stick those they call them spent fuel casks on our nuclear plant sites and just store them there for the time being.
So what kind of new technologies are we seeing when it comes to nuclear power production?
So the original light water reactor was developed to generate electricity and to cool off the uranium using this water. And it worked really well in the Navy where it was developed by Admiral Rickover because there was an abundance of water on these subs and aircraft carriers. There are some challenges. It's a little harder to keep those cores cooled off, and the accidents that we have seen have demonstrated that, right? So for example, at Fukushima, we saw that there was an earthquake that shut the reactors down successfully. The diesel generators generated power, operated the pumps, which then started circulating water to keep the core cool. But when the tsunami came, it flooded those pumps and it kept that it turned them off, and so there was no way to take the heat out. And so that can be challenging for these light water reactors, as well as we have the waste question, and even recently the cost question, that nuclear is considered expensive and difficult to pay for. And right now, there are a couple of dozen plus companies in the US that have developed advanced reactors, reactors that don't use water or that don't use solid fuel. Instead, they use liquid metals or gas or meltdown proof fuels. And these reactors are such an improvement to an already very safe technology that it's incredible. As I mentioned, some of the things that lead to a meltdown are just impossible to proceed in some of these advanced reactor concepts, and the costs are cheaper, and the waste solutions, some of these reactors, including the TerraPower reactor developed by Bill Gates's company, can actually use spent fuel as an input and get rid of some of the waste that we're concerned about. And so really the answer is a lot of these technologies have improved upon the original nuclear engineering idea, the nuclear energy idea, and have made it so that we can have better, safer, and cheaper or less waste reactors established.
So, you know, we always think of the huge nuclear reactors, the big power plants. But one new thing is these modular power production. What are those, and what's the future going to be like with that?
So really, there are a couple advantages to the modular reactors. One, it's really difficult for a utility or a company or a municipality who wants to use nuclear power to be able to afford a plant, because the upfront capital cost for these enormous gigawatt level plants is just so large. Having small plants allows you to buy just the amount of power plant that you need and then scale up as you need more and more and more. So you're allowed to amortize the capital cost, which is one of the big barriers to entry for a lot of potential customers. The second advantage is with these smaller reactors, if you can make them in a factory and ship them to a site, you can both A, make them more cheaply because they're factory fabricated instead of assembled on site, and B, you can also ship them to anywhere, including remote places like the middle of the frozen north or remote desert areas or things like this. And when you combine that with the fact that some of these advanced reactors require very little to no water, it really opens up the market to where it's more accessible to have nuclear power, and you don't have to sell the farm just to get a single plant.
Yeah, that's definitely very interesting. So looking forward, what kind of challenges are we facing when trying to push more towards nuclear power, or having that as an important power source for us?
Great question. And a lot of people have been trying to push advanced nuclear power forward. The number one barrier to entry is the licensing process. Right now, we've had a couple of new reactors that have been licensed, and they're not really technically the advanced reactors that we mentioned with all these new features. They're still light water reactors. Both of those took approximately 20 years and $1 billion just to get a license for. And so that licensing barrier is just enormous, and that makes it very difficult to move these advanced technologies forward.
And yeah, I didn't know it would take that long. Well, thank you for taking some time to delve into this. I learned a lot. Very interesting for sure.
Of course, happy to be here.